The next big topic we're going to take a look at is this idea of a confidence interval. Confidence interval is really our first look in being able to predict a parameter based on sample data. All right? So with sampling distributions, we did the other way around, where we predicted sample data probabilities based on population. So a confidence interval, let me give you an example of that. So suppose I was to ask you, for the month of January, give me an interval for what you think the average temperature was in Maryland, and also give me a level of certainty. So for instance, what you might say is that, okay, well, it was a fairly warm January, so you might say it was between maybe, let's say, 35 degrees Fahrenheit and maybe 45 degrees Fahrenheit. Okay? And if I asked you how certain you were of that, you might be 20% certain, you might be 50% certain. All right, I'm going to say I'm 80% certain. Okay, that's what a confidence interval is. Confidence interval gives you a range of values that you think that the true mean lies within, and also has a level of certainty. So this 80% certain is the level of certainty. Now, a way to be able to become more confident is just to increase that interval. So if I was to say, well, I think that the average temperature in January in Maryland was between 0 degrees Fahrenheit and 100 degrees Fahrenheit, and I'm 99% certain of that approximation. Now, unfortunately, this tells us almost nothing about the actual temperature, okay? So this is almost useless. So, the idea with a confidence interval is to be able to find a range that's narrow enough that it makes it useful, however, also find a level of certainty, okay? So, one last example of a confidence interval using the same idea, I could say that it was between 35 degrees Fahrenheit and 36 degrees Fahrenheit. But I'm almost certain that that's not the real average temperature. So I might only be 5% certain. All right. So as we notice, as the confidence interval becomes more narrow, we're usually less certain of that. As it becomes wider, as we can see right here, right, we become more certain. Right? So that's what a confidence interval is. Confidence interval is an estimated range in which we believe that a proportion or mean will lie between, and we have this level of certainty. All right? So the level of certainty was that 80, that 99, and that 5%. Now that level of certainty is called the confidence level. All right? So 99%, 5%, 80%, in those previous examples, those were confidence levels. As the confidence level increases, as we saw, so as we become more certain, the confidence interval becomes wider, and we can clearly see that going from here to here. All right? As we take more samples, the width of the confidence interval decreases. And that's just because you become more certain of the interval, so it's going to become lower. There's this animal called a margin of error that's going to determine how wide the confidence interval will be. And we're also going to have a critical value. Okay, now for us, we're only going to have two critical values for now. We're going to have this thing called Z asterisk, and whenever you see that, you just enunciate that Z critical. So whenever you see Z asterisk, you're going to call that Z critical. We're also going to have a T critical, which I'm going to show you a little bit in maybe one of the other videos. For right now, Z and T criticals are going to affect the margin of error. Okay, so Z critical is going to be a value that determines how wide the confidence interval will be. All right, so but we're going to base that on the confidence level. All right, so there's a number of these things that are going to go together. Okay, there's not much information that we're going to need from the problem to be able to create a confidence interval. Right? Now, for right now, if you know the population standard deviation, all right, and this is important, So if you know the population standard deviation, you're going to use Z critical, and these are the conversions that you're going to use. So these numbers right here, those are numbers that are going to be extremely important to you. Okay, you're going to have to either memorize those numbers, have them written down somewhere, but you're going to use them quite frequently. Okay, so for 90%, the Z critical becomes 1.645. For 95%, 1.96 will be Z critical, and then for 99%, 2.575. In the subsequent videos, we're going to show examples of how to utilize these confidence intervals and then to be able to explain what the confidence interval means. So hopefully this is a basic overview of some of the terminology. I'd encourage you to maybe re-watch it and then also to make sure that you have these down before you go through and try to work through some of the example problems.